Welcome to Sleepy Stories. In this episode, we will take a clear and steady look at water, the universe's first traveler. The goal is to help you learn while you rest. If you do not fall asleep right away, that is completely fine. In the quiet minutes before sleep, your mind can still absorb the calm rhythm of science and the wonder it reveals. Simply listen, let your breathing slow, and allow the information to settle at its own pace. Water surrounds you tonight in ways so ordinary that it feels invisible. In the glass beside your bed, the air you breathe, and the blood that moves through you. Yet every molecule in that water began its journey billions of years before Earth even existed. Hydrogen, the simplest atom, was born in the first seconds after the Big Bang. Oxygen formed later, deep inside enormous stars that lived, burned, and exploded long before the sun came to be. When those two elements met in the cold of space, they created a bond so stable that it has survived the entire history of the universe. Think about what that means. The water that quenches your thirst tonight once drifted between the stars as vapor and ice. It froze on dust grains, crossed interstellar distances, and was delivered by comets and asteroids to the surface of a young planet still wrapped in fire. It condensed, rained, froze, and melted countless times. It passed through mountains, roots, clouds, animals, and people. Every drop that touches your lips carries the memory of that immense journey. As you listen, imagine tracing that journey backward, beyond the oceans and clouds, past the formation of the solar system, back through the silent ages when galaxies were still gathering their stars. Follow it to the beginning, to the moment when the first atoms appeared out of light. There, in that newborn universe, hydrogen took its place as the first building block of everything that would ever exist. We will travel with that atom as it becomes part of a molecule, part of a star, part of a world, and finally part of you. The story of water is the story of motion, endurance, and transformation, a cosmic voyage still unfolding with every breath you take. So tonight, let the thought of that endless traveler bring you ease. Whether your eyes close quickly or stay open a little while longer, you are already part of the same flow that links oceans to clouds and galaxies to life. Take a deep breath, feel its coolness, and let the air settle softly in your lungs. The universe has been carrying this element across time to reach you. Before we begin our journey through its history, remember that this space is yours to rest. There is nothing to solve, nothing to chase. You can simply drift with the current of ideas, letting them move as gently as waves over sand. And if you find peace in the sound of discovery, you can support these explorations by liking and subscribing, helping new listeners find their own quiet place among the stars. Now, as your breathing evens out and your body grows still, we follow the first traveler to its origin, to the universe's earliest breath, when everything began. Imagine the universe in its first moments. Not darkness, not stars, but pure energy. Time itself had just begun. The Big Bang was not an explosion in space. It was the sudden expansion of space itself, a transformation from unimaginable density into a growing, cooling cosmos. In the first fraction of a second, temperatures were so high that even atoms could not exist. Particles flickered in and out of being, colliding, annihilating, and appearing again in a storm of creation. As the universe expanded, it began to cool. Out of that intense heat, the simplest structure imaginable found stability, the proton. It is little more than a single bundle of energy wrapped in matter, but it would become the cornerstone of all chemistry. When these protons paired with electrons, the first atoms were born. Hydrogen, the universe's first and most enduring element. Hydrogen made up the majority of everything that came next. It filled the cosmos like a diffuse mist, so thin that you could travel light years without meeting another atom, yet so abundant that its combined mass shaped the fate of galaxies. Hydrogen was the raw material from which all later forms of matter would arise. Every star that has ever shone, every planet that has ever formed, began with these simple atoms drifting in the young universe. In the beginning, this hydrogen did little more than exist, but gravity, the faint attraction between masses, began to gather it. Slowly, over millions of years, hydrogen clouds thickened. The process was invisible and silent, but relentless. As clumps grew denser, gravity pulled them tighter, their centers heating under pressure. When the heat became great enough, the atoms began to fuse. Two hydrogen nuclei joined to form helium, releasing energy as light. The first stars were born, and with them, the first illumination of the cosmos. Those early stars were enormous, hundreds of times the mass of our sun. And short-lived, their brilliance filled the universe with radiation, transforming hydrogen into new elements through fusion. But before any of that, before oxygen, carbon, or life, hydrogen stood alone, the first breath of the universe, the simplest whisper of existence. Even now, billions of years later, hydrogen remains the most common element. About 3/4 of the visible universe is still made of it. The same atoms that floated through that primeval darkness continue to move through stars, planets, and living bodies. Each breath you take contains hydrogen born in that first era. When you exhale, it returns to the world, unchanged in essence, continuing its journey. To understand hydrogen is to glimpse the unity of creation. It has no color, no scent, no taste. You cannot see it, but its presence is everywhere. When you light a candle, hydrogen combines with oxygen in the flame, producing water and heat. When you look at the sun, you are seeing hydrogen transformed into light. The oceans, the clouds, the air, all depend on the bonds that began forming when hydrogen first cooled and found stability. Think of it as the universe's simplest promise. From simplicity, all complexity can arise. One proton, one electron, nothing more. Yet, out of that minimal structure came everything else. Every atom in your body exists because hydrogen made the first move toward order in a sea of chaos. When you look up at the stars tonight, the light that reaches you is ancient hydrogen's legacy, the energy released when it fuses within stellar hearts. The glow of every galaxy is hydrogen remembering how to shine. As you rest, hold that thought gently. The air that fills your lungs is part of that same story, woven through the universe's earliest breath. The element that began all matter is still here, still alive in flame and wind, in sea and skin. From that first whisper of existence came the foundation of water, the traveler that would one day find its home on Earth. Next, we will follow the path of transformation to the fiery hearts of stars, where hydrogen meets its destiny and gives birth to oxygen, the second essential partner in the long journey toward life. From the quiet sea of hydrogen that filled the young universe, stars were born, immense spheres of gas bound by gravity and sustained by fusion. Within their cores, the pressure was staggering. Temperatures reached millions of degrees, enough to overcome the natural repulsion between atomic nuclei. Here, hydrogen began to fuse into helium, releasing vast amounts of energy. The light from these first stars spread across the dark universe, and with it, the story of transformation began. Hydrogen was simple, but the universe sought complexity. In the heart of massive stars, fusion continued beyond helium. When hydrogen fuel ran low, gravity squeezed the core tighter, raising temperatures still higher. Helium nuclei began colliding, fusing into carbon, and in subsequent reactions, carbon fused again with helium to produce oxygen. This was the origin of the air you breathe, the oxygen in your blood, and the oxygen bound within every water molecule that surrounds you. Each atom of it was once forged in the furnace of a star. The process was violent, yet perfectly balanced. For millions or even billions of years, stars held steady, their radiation pushing outward against the inward pull of gravity. This equilibrium defined their lives. But no balance lasts forever. Eventually, The core's fuel ran out. When fusion could no longer resist gravity, the star collapsed. In the final moments, its outer layers exploded outward in a supernova, scattering newly formed elements, oxygen, carbon, iron, and many others, into space. These were the materials that would one day build planets, oceans, and life itself. In that sense, stars are both creators and destroyers. They build the ingredients for water and life, but they must die to share them. Each explosion seeded the surrounding galaxy with oxygen, blending it into clouds of hydrogen already adrift in the cosmic dark. The dust and gas left behind glowed faintly, illuminated by the light of surviving stars, waiting to be drawn together again by gravity into new systems. The universe became a recycling network, its matter endlessly reborn. The oxygen you inhale this very moment once endured temperatures hotter than any furnace on Earth. It survived collapse and explosion, traveled across the emptiness between stars, and became trapped within the dust that eventually formed our solar system. It is, in every sense, star blood, the residue of suns that no longer shine. When we say that we are made of stardust, this is what we mean. The calcium in your bones, the iron in your blood, and the oxygen in every cell were all forged in stellar cores. Life itself is a continuation of the star's work. The next time you take a breath, consider that the gas filling your lungs began its existence in the fiery heart of a long-dead sun. You are, quite literally, inhaling history written in light. The creation of oxygen transformed the universe. It allowed new kinds of chemistry, more complex molecules, and eventually, the first water. Without oxygen, there would be no oceans, no atmosphere, and no life as we know it. The pairing of hydrogen and oxygen was inevitable, two elements born in completely different eras, destined to find one another in the silence of space. As you rest and imagine those distant furnaces, know that every flicker of starlight you see tonight carries that story. Each glow is a factory of elements, a beacon of creation shining through the dark. The oxygen that now moves quietly through your blood, once blazed at the core of a star, survived its death and journeyed across billions of years to reach you. In our next step, we will follow what happens when these two ancient wanderers, hydrogen and oxygen, finally meet, not in fire, but in the deep cold of space, where water is born for the first time. Far beyond the glow of any star lies a silence deeper than anything we can experience on Earth. There, between the bright islands of galaxies, stretch vast clouds of gas and dust, the raw material of future worlds. These regions, called molecular clouds, are the dark nurseries of the cosmos. They are so cold that heat barely exists, so thick with particles that light cannot pass through them. And it is within these shadows that something extraordinary begins to unfold. Hydrogen and oxygen, after drifting separately for billions of years, finally meet. Inside these clouds, conditions are so gentle and slow that chemistry proceeds at a whisper. Tiny dust grains, made of silicates and carbon compounds, act as meeting grounds for atoms. An oxygen atom lands upon a grain, clinging faintly to its surface. Soon after, a wandering hydrogen atom touches it, and a bond forms. Another hydrogen arrives, and suddenly there is something new in the universe, a molecule of water. It is a moment of stillness, a quiet triumph of physics and time. This process happens everywhere in the galaxy, but at an almost unimaginable pace. In the thinness of interstellar space, collisions between atoms are rare. A single molecule might take 1,000 years to form. Yet over millions of years, and across clouds that stretch for light years, these tiny acts add up. The universe, patient and persistent, weaves water one molecule at a time. For astronomers, these clouds are invisible to the naked eye, but radio and infrared telescopes reveal their secrets. Within their signals, scientists detect the faint spectral fingerprints of water and other molecules. These discoveries show that water is not confined to planets or comets. It exists almost everywhere, frozen, vaporized, or hidden in dust. It is one of the most common molecules in the universe, second only to hydrogen itself. The stillness of molecular clouds hides immense potential. Over time, gravity gathers their contents into denser pockets. As they collapse, these pockets form new stars surrounded by disks of gas and ice, the birthplace of solar systems. But long before the first sunlight shines upon them, water already exists there, waiting. It is born not from fire, but from cold, silence, and patience. To imagine this process is to see beauty in slowness. On Earth, we think of creation as something active, a volcano erupting, a storm forming, a seed bursting from the ground. In space, creation can be almost motionless. Atoms drift through darkness for millions of years before meeting, yet that meeting is enough to shape the chemistry of worlds and the possibility of life. Every molecule of water around you today carries that legacy. Each was formed when two tiny atoms found one another in a darkness so deep it defies thought. They bonded quietly, froze onto dust, and traveled through the galaxy for eons before joining planets and oceans. In a sense, water was complete long before Earth was born. Our planet merely gathered it from the ancient reservoirs of the cosmos. As you breathe and feel the air move through you, remember that the same elements were once suspended in that darkness, waiting to combine. They met without light or sound, guided only by the subtle pull of forces that govern everything. From that quiet beginning came the streams, rivers, and oceans that now define our planet. In the next part of this journey, we will remain among those clouds a little longer, to see how those fragile molecules of water, newly born in darkness, freeze onto dust and become the hidden reservoirs that will one day build worlds. In the depths of interstellar space, where sunlight has never reached, water settles into its first form of permanence, ice. Each molecule that formed in the stillness of molecular clouds finds itself drawn to a dust grain, clinging there and freezing solid. Over time, thin coatings of ice build up, layer upon layer, until every particle becomes a tiny frozen world. These grains drift quietly through the dark, untouched for millions of years. Together, they make up vast, cold clouds that stretch across light years, invisible to human eyes, yet containing more water than all the oceans of Earth multiplied many times over. At these temperatures, only a few dozen degrees above absolute zero, everything slows to near stillness. Chemical reactions that would flash instantly on Earth unfold here at a pace so slow it is almost outside the scale of imagination. Yet this is precisely why these frozen ices are so valuable. They act as time capsules, preserving the chemistry of the universe in its purest form. When astronomers observe them with infrared telescopes, they detect distinct spectral signatures of water, carbon monoxide, methane, and simple organic molecules, the same building blocks that will later feed planets and, eventually, life. The beauty of these frozen grains lies in their patience. Each one drifts for millions of years, gathering more layers of ice as it moves through denser regions of the galaxy. When two grains meet, they sometimes stick together, forming clumps. Gravity will one day pull these clumps into larger structures, asteroids, comets, and the raw material of planets. In this way, every ocean and cloud that will ever exist begins as frost on interstellar dust. Imagine a grain of dust smaller than a speck of smoke, floating in absolute silence. Around it, space stretches endlessly. No sound, no light, only darkness. And yet, on its surface, a thin shell of ice glows faintly under distant starlight, hydrogen and oxygen bound together, waiting. In that small shell lies the story of everything that will come. Oceans, rivers, rain, and all the life those waters will sustain. From a scientific view, this stage of the story is crucial. The frozen grains of water serve as the delivery system for future worlds. Without them, planets forming later would begin dry and barren. It is these icy seeds that ensure water is present wherever the right conditions arise. When a new star ignites, the heat from its radiation begins to melt or vaporize nearby ice, releasing water into the surrounding space, enriching young solar systems with moisture. But before any of that, these icy mantles must endure eons of stillness. They drift in darkness so complete that even nearby stars fail to cast a shadow. Occasionally, cosmic rays pass through, releasing faint energy that sparks new chemical reactions, creating traces of ammonia, alcohols, and simple sugars. What begins as frozen water slowly becomes a frozen chemistry lab, quietly preparing ingredients for future biology. As you imagine this frozen ocean of dust and ice, think of how it mirrors stillness within yourself, the way deep calm allows quiet formation, unseen but vital. The universe does not rush, even in its coldest corners. Creation continues patiently, shaping futures molecule by molecule. When gravity finally gathers these frozen grains together, they will journey toward the light, carried into new star systems where heat will awaken them. Some will fall into young planets, others will remain as comets, circling silently in the dark. They are, in every sense, frozen messengers, archives of the universe's first water, waiting to tell their story when they finally meet the warmth of a newborn sun. Next, we will follow those icy wanderers as they are drawn from the edges of the solar system toward the light, carrying the ancient water that will one day fall as rain upon a young, blue world. At the frozen outskirts of the solar system, far beyond the orbits of the planets, countless icy bodies drift through the dark. These are comets, fragile relics from the earliest days of creation, unchanged since the time when the sun and planets first formed. Each one carries a record of the universe's youth, its core made of rock and dust wrapped in ice that has endured for billions of years. They are travelers from the edge, messengers bearing water from an age before Earth had oceans. Most of the time, these messengers remain hidden. They circle the sun from great distances, locked in frozen silence within the Kuiper Belt or the far-off Oort cloud. For millions of years, they drift undisturbed until a gravitational nudge, perhaps from a passing star or the pull of a giant planet, alters their path. Slowly, they begin to move inward. As they approach the sun, the warmth awakens them. Ice vaporizes, gases expand, and a faint glow appears around the solid core. This is the coma, a thin, luminous atmosphere that surrounds the nucleus. As solar radiation pushes against it, long tails of dust and gas stream outward, stretching across millions of kilometers. From Earth, we see them as bright streaks moving through the night sky, their tails like ancient handwriting across the stars. But what we are really seeing is water, vaporized ice, releasing not just hydrogen and oxygen, but the chemistry of the early solar system. Each comet is a time capsule, containing frozen molecules of water, carbon dioxide, ammonia, and organic compounds that formed long before Earth existed. Scientists study comets to understand how water arrived on our planet. In 2014, the European Space Agency's Rosetta mission orbited comet 67P Churyumov-Gerasimenko, analyzing its composition. What it found was both fascinating and humbling. The water on that comet had a different ratio of hydrogen to its heavier isotope, deuterium, than the water in Earth's oceans. This told scientists that comets like 67P could not be the sole source of Earth's water, but they almost certainly played a part. Other comets, originating in different regions of the solar system, may have carried water that matches our own more closely. The discovery reshaped our view of water's origin. Rather than a single delivery, Earth's oceans likely came from many sources: comets, asteroids, and the planet's own interior, each contributing over millions of years. Comets, with their pure ices and ancient chemistry, represent one of those vital streams of inheritance. When they strike planets, they release their water in an instant, transforming frozen memory into rain, vapor, and eventually ocean. From a scientific standpoint, comets are remarkable because they preserve the conditions of the solar system's birth. From a reflective standpoint, they are reminders of time itself. A comet seen tonight may not return for thousands of years, yet it follows a path set in motion before humanity existed. Its journey is a cycle of approach and retreat, of awakening and silence. It is water on a pilgrimage through light and dark, destined to repeat its orbit long after we are gone. Think of a single comet nearing the sun, a speck of rock and ice, glowing against the blackness of space. Its tail arcs across the void, shedding water that was once frozen in molecular clouds, the same water that will later fall as rain on some distant world. It is a messenger of continuity, carrying the story of the universe in every evaporating particle. As you picture it moving through the night, imagine that trail of vapor stretching back through time. It connects the birth of stars to the rise of oceans, and the cold of space to the warmth of your own breath. Each comet is proof that nothing in nature ever truly ends. It only travels, transforms, and returns. Next, we will follow another kind of traveler, not bright like the comets, but quiet and hidden. The asteroids that carried water locked in stone, shaping the Earth drop by drop. Between Mars and Jupiter lies a vast region filled with rocky fragments, remnants from the time when the planets were still forming. These are asteroids, the quiet cousins of comets. They do not shine with tails of vapor or announce their presence with brilliance. Instead, they drift in silence, following patient orbits around the sun. To the eye, they seem lifeless, simple stones in the dark, yet hidden within many of them is one of the universe's most precious materials, water. When the solar system was young, heat from the newborn sun created a boundary between warm and cold regions. Beyond that line, ice could exist. Within it, water had to find shelter in other ways. Inside the asteroids, chemical reactions allowed water to bond directly to minerals, forming what scientists call hydrated silicates. These minerals do not glisten with ice or release vapor. Their water is held at the atomic level, woven into the rock itself. Each stone became a storage vessel, carrying hydrogen and oxygen locked in place for billions of years. Occasionally, these asteroids collided, breaking apart and scattering fragments through the inner solar system. Some were drawn toward the planets, their trajectories shifted by gravity. When one struck Earth, the impact was immense. The energy released could melt rock, carve craters, and scatter debris high into the air. Yet within that violence, water was released. As the minerals shattered, the bound hydrogen and oxygen combined, forming vapor that rose into the sky. Over time, repeated impacts built up the supply of water that would later cool, condense, and fill the first basins of the planet. Evidence of this hidden cargo has come to us from meteorites that land on Earth. When scientists examine these fragments, they find traces of water bound within their minerals, even after billions of years in space. Some meteorites contain amino acids and carbon compounds, the basic ingredients of life. In their chemical makeup lies a record of the early solar system's complexity. They remind us that life's story did not begin on Earth alone, but was written into the stones that fell from the sky. In the past decade, spacecraft have visited several asteroids to study them directly. Missions like Japan's Hayabusa 2 and NASA's OSIRIS-REx touched the surfaces of Ryugu and Bennu, collecting samples to bring home. Images from these missions show landscapes of shadow and dust, places where sunlight glints off ancient rock. Within that rock lies confirmation that water once flowed through these bodies, not as rivers, but as reactions inside minerals, preserved ever since. These discoveries prove that the asteroids were not barren rubble but participants in the formation of habitable worlds. It is striking to think that Earth's oceans, so vast and alive, may have begun with deliveries from such modest couriers. Each impact added only a small amount of water, but across millions of years, the accumulation became enormous. Drop by drop, collision by collision, the seas grew. The surface of the planet transformed from molten stone to blue reflection. In that transformation, the asteroids played their quiet part, leaving no bright tail, no trace of fire in the sky, only the enduring gift of water. Even now, they continue their slow orbits, unchanged since the dawn of time. Some remain in the main belt, others travel on paths that cross Earth's own. They are relics of creation, reminders of how the universe stores its treasures in silence. To look at them through a telescope is to see the memory of our beginnings, still drifting through the dark, carrying inside them the same molecules that move through our veins. The water that once hid in those stones now covers most of our world. It fills the oceans, flows through rivers, rises into clouds, and returns again as rain. The asteroid's secret cargo has become the rhythm of the planet, a rhythm that continues, unbroken, from the earliest days of the solar system to every drop that falls today. Every element that exists is part of a vast cycle. Stars create, collapse, and scatter, and from their remains new stars and planets emerge. Nothing is wasted in the universe. The same atoms that once blazed within a star's core can later rest in a rock, flow through an ocean, or move quietly through the air. The story of water is inseparable from this grand recycling, a process that repeats endlessly across space and time. When a massive star nears the end of its life, its balance begins to fail. For millions of years, nuclear fusion has kept it stable, turning hydrogen into helium and helium into heavier elements like carbon, oxygen, and iron. But eventually, fusion can go no further. Gravity takes over. The core collapses inward in a fraction of a second, and the outer layers explode outward with unimaginable energy. A single supernova can outshine an entire galaxy for weeks, releasing more power than our sun will emit in its entire lifetime. In that explosion, the universe renews itself. Elements forged in the star's interior are flung into space, scattered through the galaxy at tremendous speed. The surrounding clouds of gas absorb these materials, becoming richer with each generation of stars. Over time, new systems form from this enriched matter, containing not just hydrogen but the oxygen and carbon necessary for water and life. Every planet, every ocean, every living being is built from material that once belonged to a star that died long ago. Astronomers can trace this cycle by studying the light from distant remnants of supernovae. The colors of that light reveal the presence of oxygen, carbon, and other heavy elements drifting outward as fine dust. In these clouds, we can see the continuity of creation, the ashes of stars becoming the seeds of worlds. Without these explosions, galaxies would be barren, their gas too simple to form complex chemistry. Instead, the universe reuses its ingredients, folding them again and again into new shapes. It is strange to realize how connected we are to this rhythm. The oxygen you inhale came from such a star. The iron in your blood once existed in the core of another. Even the calcium in your bones was born from stellar fusion. You are a continuation of the stars' work, a living extension of their creation and destruction. In that sense, the universe is not a collection of separate events, but one ongoing process, a vast organism that renews itself endlessly through time. Water, too, participates in this exchange. When stars explode, their shock waves pass through molecular clouds, stirring their contents, mixing old material with new. In the cold regions behind the shock, atoms meet again, forming fresh water molecules that freeze onto dust grains. The same process that destroys stars also helps create the molecules that will one day become oceans. Even in destruction, the universe builds. Even in fire, it prepares for life. On Earth, we see smaller reflections of that same pattern. Forests burn and regrow. Rivers carve new paths through stone, carrying sediment from mountains to the sea. The cycle of creation and decay is not a tragedy. It is balance. What disappears in one form reappears in another. The stars showed us this long before our planet existed. When you look up at the night sky, the faint glow of the Milky Way is more than a scatter of light. It is a panorama of renewal. Every point you see is a star participating in this endless exchange, producing the elements that will one day form new worlds. The space between them, dark and seemingly empty, is filled with the debris of old suns, still moving, still useful. The universe wastes nothing. It transforms. The water that moves through you tonight has passed through these cycles of creation and destruction countless times. It carries traces of stars that no longer exist, yet their presence lives on in every molecule. To drink, to breathe, even to exist is to participate in that eternal recycling, the quiet assurance that nothing is ever truly lost. Out in the vast reaches of our galaxy, where the debris of ancient stars drifts and gathers, enormous clouds of gas and dust begin to take shape. These are nebulae, the birthplaces of stars and planets, immense and luminous in some places, dark and hidden in others. Within them, gravity slowly begins its patient work, pulling matter together until it folds in on itself. Out of this slow motion, new stars will ignite, and around them, disks of gas and ice will swirl, the foundations of new worlds. These clouds are not uniform. They are full of filaments, pockets, and turbulence, the physical result of earlier explosions and the steady breath of starlight. Within the denser regions, particles of dust coated in frozen water start to collide. They stick together, forming clumps that grow grain by grain. Over millions of years, those clumps turn into pebbles, then rocks, then the cores of planets. Inside each one, the ancient water from earlier generations of stars becomes part of a new beginning. The scale of these processes is almost impossible to comprehend. A single cloud can stretch across hundreds of light years and contain enough material to form thousands of stars. Yet the chemistry within it is familiar and intimate. Water molecules, carbon compounds, and simple organic molecules drift together in temperatures just a few degrees above absolute zero. In the darkness, radiation from nearby stars causes faint reactions on the icy surfaces of dust grains, creating ever more complex combinations of atoms. Each cloud becomes a slow, cold laboratory where the ingredients for life quietly assemble. Astronomers have mapped many of these nurseries. Through infrared telescopes, they can see the telltale fingerprints of water and other molecules. The Orion Nebula, for example, is one of the closest and most studied. In its glowing folds, countless new stars are forming, each surrounded by a disk of matter that will become planets and moons. Within those disks, water is already present, frozen into ice, waiting for heat and time to awaken it. When the first planets form, that ice will melt, evaporate, and rain down again, the same water that once drifted unseen in interstellar space. These clouds are not quiet in the way we imagine silence. They are alive with invisible movement. Magnetic fields twist and stretch them. Shock waves from distant supernovae pass through, compressing gas and triggering new rounds of star formation. The entire galaxy breathes through these structures. Stars are born, live their lives, die, and return their matter to the same clouds, enriching them further with each generation. The water that condenses there is not new. It is old material reassembled, passed from one cosmic age to another. If you could stand within one of these nebulae, though no human could survive its cold and thinness, you would see soft glows of pink and blue where starlight excites the gas. The darker regions, where the light cannot penetrate, are where the most important chemistry occurs. There, dust grains coated with ice wait, gathering quietly in the shadows. It is inside those frozen shells that the future of entire worlds begins. Everything that follows, the formation of stars, the spinning of planets, the arrival of oceans, depends on the slow work happening here. From a distance, the galaxy looks serene, but within these clouds lies constant change. They are the womb of everything solid, the quiet link between the fire of stars and the water of worlds. Each drop that now falls as rain on Earth once drifted through a nebula like this, frozen to a grain smaller than a grain of sand, waiting for its chance to join a planet. The clouds of creation do not just give birth to stars, they give birth to the conditions for life, carrying forward the same water that began forming long before our sun existed. The newborn Earth did not begin as a place of calm oceans and blue skies. It was a world of fire. More than 4.5 billion years ago, the dust and debris left from the sun's formation began to collide and merge under the pull of gravity. Countless impacts fused the fragments together, creating a planet that glowed from the energy of its own birth. The surface was an ocean of magma, restless and alive with heat. Volcanoes erupted continuously, pouring rivers of molten rock across a landscape that never cooled. Above this fiery surface, the air was thick and toxic, a swirling mix of carbon dioxide, nitrogen, and sulfur compounds. Temperatures were so high that even solid rock softened and flowed. The sun shone weakly through clouds of vaporized minerals and dust, but its light did not reach the ground. Nothing resembling liquid water could exist. Any ice that fell from space vaporized instantly. Any vapor that condensed was torn apart by heat. It was a world where stone behaved like liquid and water was only a memory of the stars. Yet hidden within this chaos were the seeds of transformation. Deep inside the planet, elements continued to separate and settle. Iron sank toward the center, forming the core that would one day generate Earth's magnetic field. Lighter materials floated upward, creating a thin, unstable crust that cracked and melted with every impact. Each meteorite that struck the surface released new energy, new metals, and, in some cases, traces of water bound within its minerals. Most of it escaped into space, but some lingered, absorbed into the molten rock or trapped within the forming atmosphere. Gradually, the bombardment slowed. The sun grew steadier, and the debris left from planetary formation began to clear. Though the surface remained unimaginably hot, the Earth was changing. Gases from its interior rose through vents and fissures, forming a dense shroud around the planet. This early atmosphere held enormous amounts of steam, water vapor released from minerals deep below. It was not yet the gentle sky we know, but it was the beginning of one. Imagine standing on that young world, though no living thing could have survived there. The horizon would have glowed orange and red, streaked with lightning that flashed silently through dense clouds. Every mountain would have been a volcano, every valley a river of fire. The air would have shimmered with heat, and the ground itself would have flowed like metal. Beneath it all, the planet's interior boiled and shifted, carrying heat from its core to the surface in waves of molten motion. Even in this inferno, the presence of water mattered. Locked within minerals, rising as vapor through cracks, or waiting in icy bodies that still fell from the sky, water was already part of Earth's story. Though it could not yet flow or pool, it gathered invisibly in the planet's chemistry, preparing for the moment when the surface would finally cool enough to hold it. The planet's youth was violent, but it was also a process of foundation. Without this molten stage, Earth would not have developed its layered structure or magnetic shield. Both would later prove essential for keeping the atmosphere and the water within it from escaping into space. Fire, paradoxically, made the future possible. From the distance of time, it is difficult to imagine that this chaotic, red-hot sphere would ever become a place of blue oceans and green continents. Yet every drop of water that would one day ripple under sunlight was already here in some form, bound in stone, floating as vapor, or waiting in the icy debris still falling from space. The earth was still molten, but the transformation had already begun. The long journey from fire to water was underway, and the world, though violent, was slowly preparing to breathe. After millions of years of unrelenting heat, the newborn Earth began to change. The bombardment that had scarred its surface lessened, and the planet slowly released some of the energy trapped within its molten depths. What had once been a churning ocean of magma began to cool and solidify into the first thin crust. It cracked and shifted constantly, torn open by the pressure of the molten rock beneath it. But for the first time, there was ground, unstable, scorched, yet solid enough to exist above the fires below. Through those cracks, volcanic gases poured into the sky. Carbon dioxide, nitrogen, sulfur compounds, and, most importantly, water vapor escaped in vast quantities. The atmosphere thickened, forming a heavy, dark veil that trapped heat close to the ground. Lightning flashed endlessly across the haze, striking volcanic plumes that reached high into the air. The surface was still far too hot for liquid water, but something crucial was happening. The steam from Earth's interior was beginning to gather, rising into the upper layers of the atmosphere, where temperatures were cooler. There, for the first time, clouds began to form. Those clouds would not have been white or gentle. They were massive and dark, tinted red by the glow of molten rock below, dense with vapor and ash. As they swirled and collided, droplets of condensed water began to fall, only to vanish before reaching the ground, turned instantly to steam by the heat. Still, they fell again and again. It was as if the planet was learning to reign, testing the balance between fire and water, seeking the temperature at which the two could coexist. Volcanic eruptions became part of this rhythm. Each explosion released more vapor, feeding the clouds that hovered above. The air thickened with moisture. Gases that had once been trapped in the planet's core now drifted freely through its sky, transforming it from a hostile void into a growing atmosphere. The rain that rose and vanished became part of a slow cycle, cooling the surface a little more each time. Eventually, the balance began to shift. The rock, once white-hot, darkened as it cooled, and the air began to lose some of its suffocating heat. The first raindrops that survived long enough to touch the ground must have hissed when they struck, evaporating instantly into vapor. But over countless years, as the temperature fell, more droplets endured. They rolled across jagged rock, pooled in cracks, and ran down slopes into low basins. Every drop carried minerals from the newly solid crust, beginning the slow erosion that would shape continents and valleys. With each storm, the planet cooled further. The clouds grew denser, the rain heavier, and the surface began to steam less violently. From space, the transformation would have been remarkable. The bright orange glow of a molten world faded under a veil of cloud, replaced by darker tones of grey and blue. Earth was beginning to calm. Its face was no longer purely fire. It now held the first hints of water, not yet oceans, but vapor and rain, promise and beginning. Volcanoes continued to dominate the landscape, feeding the sky with heat and moisture. Their eruptions may have sounded like the planet's breath, exhaling the water it had carried deep within since its formation. That vapor, once trapped in rock, was now part of the air, part of the growing cycle between Earth and its sky. Though still wild and unstable, this was the moment when the world first began to resemble the one we know. The line between fire and rain had been drawn, and the planet was learning balance. Water could exist, at least for moments, before turning back into mist. The clouds thickened, the storms grew longer, and the surface continued to cool. The fiery earth was beginning to hold its breath, and with it, its first rain. The rhythm of fire and rain continued for ages, a balance slowly tipping toward calm. The planet, once entirely molten, had begun to breathe in cycles: eruptions, steam, condensation, and the returning fall of water. Over millions of years, the energy radiating from Earth's surface weakened. The atmosphere, dense with carbon dioxide and vapor, acted like a blanket, trapping heat but also allowing it to escape gradually into space. With every storm, with every drop that fell and hissed into vapor, the world cooled another degree. The first true rains that reached the ground must have been immense. They fell not for hours or days, but for centuries, then millennia. Water poured from the dark clouds, cascading onto blackened rock that still steamed and cracked from within. The sound would have been a constant roar, rain hammering molten plains, vapor rising in curtains that blurred the horizon. Slowly, pools formed in the low places, merging into lakes that boiled, cooled, and filled again. The relentless cycle of heating and cooling carved channels into the surface, shaping the planet's first features. During this time, the crust thickened and grew stronger. Large patches of land resisted melting and began to rise above the surrounding terrain. Basaltic plains stretched across vast areas, cooling under endless storms. The young Earth was still hostile, but it was beginning to find equilibrium. Gases, once trapped in the atmosphere, dissolved into the falling rain, altering the air's composition. Carbon dioxide reacted with the cooling rock, binding into minerals. The result was a slow decrease in greenhouse gases, which in turn allowed the temperature to fall even further. As the heat subsided, the rain became less violent. The water that reached the ground lingered longer before evaporating. Streams began to run downhill, collecting in larger and deeper basins. Steam still rose, but it no longer erased every drop. Some water stayed, thin films over stone, small pools that reflected the dim red light filtering through the clouds. With each century, those pools grew wider, deeper, more persistent. The hydrological cycle as we know it was being born: evaporation, condensation, rainfall, and runoff, all working together to transform a molten world into a wet one. From above, the view of Earth would have changed completely. The orange glare of magma fields gave way to darker continents streaked with rivers of rainfall. The atmosphere, once thick with dust, began to thin as heavy particles settled. Lightning still flashed through the skies, but between the clouds were glimpses of grey-blue surfaces, the first reflections of liquid water. Inside the planet, heat still moved upward, feeding volcanoes that erupted again and again, replenishing the atmosphere with steam. Yet each eruption only added to the water above, and the balance continued to shift. The planet that had once burned endlessly was cooling into one that could host oceans. The chemistry of this new environment was extraordinary. Water interacted with the basalt crust, leaching elements like sodium, magnesium, and calcium into solution. These minerals changed the water's composition, turning it slightly salty, a property that has remained ever since. Rainwater wore down the landscape, carrying sediments toward the lowest points. Each storm deepened the grooves of rivers and filled the depressions that would soon become basins. The transformation was not gentle, but it was steady. Over immense spans of time, the planet moved from fire to flood. The heat of creation yielded to the patience of erosion. What had been chaos became rhythm. Rain falling, rivers forming, steam rising, clouds gathering. In that rhythm, the earth finally began to cool enough for water to stay. The surface hardened, the skies cleared in places, and the horizon took on the shimmer of liquid light. What had once been a planet of flame was becoming a world of reflection. The great cooling had given water its first true home, and the long journey of the universe's oldest traveler had found a place to rest, at least for a while. Even as rain continued to shape the surface, the skies above the young Earth were alive with fire. Across millions of years, countless objects fell from space, remnants of the solar system's formation still wandering between the planets. Many were small, no larger than mountains, but others were massive enough to leave scars that would last for eons. These were comets and icy planetesimals, ancient wanderers carrying the water formed in distant regions of the solar system. Their arrivals were violent, yet each one brought a precious gift. When a comet entered Earth's atmosphere, friction ignited it into a blazing arc of light. Its icy heart vaporized, releasing gas and water in a brief, brilliant storm. Fragments that survived impact crashed into the surface, releasing bursts of steam and molten debris. Each collision was an act of destruction, but also of delivery. The ice within these bodies carried hydrogen and oxygen that had been frozen since the dawn of the solar system. When they struck Earth, that frozen memory became vapor, then rain, adding to the deepening reservoirs that covered the cooling planet. During what scientists call the late heavy bombardment, this process happened on a colossal scale. For hundreds of millions of years, Earth and its neighboring worlds were battered by constant impacts. The Moon's cratered surface still bears the marks of that era, preserved like a record of the violence our planet endured. But while the Moon remained dry, Earth's atmosphere and molten surface absorbed the blows differently. Much of the incoming water was captured, condensed, and stored in basins that were slowly forming across the crust. The chemistry of this imported water has long intrigued scientists. Using isotopic measurements, they can compare the ratio of hydrogen to its heavier form, deuterium, in Earth's oceans with that found in comets. Some comets show a close match, suggesting that at least part of our water came from these icy travelers. Others show slight differences, pointing to a more complex origin, a blend of sources that together built the seas we know today. Whether they supplied most of Earth's water or only a portion, their contribution was significant. They enriched the planet not only with water, but also with organic molecules, carbon compounds that would later play a role in the emergence of life. To imagine those impacts is to picture the sky alive with fire. Each night, streaks of light would have crossed the heavens, some ending in flashes that shook the ground, others burning out quietly in the upper atmosphere. Every explosion filled the air with vapor that condensed into rain. The cycle of delivery and condensation never stopped. Bit by bit, comet by comet, the world's water supply grew. For the planet itself, this rain of ice was transformative. The oceans that were just beginning to form received new water from the cosmos, mingling it with vapor from volcanic outgassing and with moisture condensed from the atmosphere. The seas expanded, the surface shimmered with liquid, and the air thickened with clouds. What had once been a barren world of rock and heat was now wrapped in weather. It is humbling to think that the water falling as rain today once drifted for billions of years through the cold of interstellar space, frozen onto dust grains or locked inside ancient comets. Those wanderers traveled across the darkness, untouched and unseen, until gravity drew them toward a small, blue world, still in its making. Their journeys ended in fire, but their substance endured, melted, evaporated, and returned as rain. The comets that once streaked across Earth's young skies no longer visit as often, but their legacy remains in every river, every lake, every glass of water. The collisions that once seemed chaotic were, in truth, acts of creation. The universe in its own way was generous. From the edge of the solar system came the gifts that turned fire to ocean, silence to storm, and dust to life. While comets brought their icy offerings from the outer reaches of the solar system, another, quieter source was at work much closer to home. Deep within the asteroid belt, that wide expanse of rock orbiting between Mars and Jupiter, lay bodies that looked dry and lifeless, yet carried water in a form no eye could see. These asteroids were not made of ice, but of stone infused with minerals that had once reacted with water long ago. Inside them, molecules of hydrogen and oxygen were bound to silicate crystals, locked in place since the earliest days of planetary formation. When these rocky travelers struck Earth, they brought with them a hidden cargo. The impacts were smaller and more frequent than the spectacular cometary collisions, but their contributions were steady and they added up over time. The intense heat of each impact released the water trapped within their minerals. Hydrogen and oxygen recombined as vapor, rising into the atmosphere, condensing, and eventually falling again as rain. What seemed like dry stone from the void turned out to be another vessel of the same cosmic traveler, water in a deeper, more secret form. Clues to this story still fall from the sky today. Meteorites recovered on Earth often contain traces of these hydrated minerals. Under a microscope, they reveal tiny pockets of water that have remained unchanged for billions of years. Some even carry amino acids and carbon compounds, evidence that the same processes that created oceans may also have delivered the chemical seeds of life. Each meteorite is a fragment of history, a small message from the time when Earth was still being built, showing that the universe had hidden many of its gifts in stone rather than ice. Modern spacecraft have confirmed this ancient connection. When Japan's Hayabusa 2 mission visited asteroid Ryugu and NASA's OSIRIS-REx touched down on Bennu, both found minerals containing bound water. The samples returned from these missions show that water was not rare in the inner solar system. It was everywhere, quietly stored in the very fabric of rock. These discoveries reveal that our planet's hydration was not the result of a single dramatic event, but a long, cumulative process that involved countless silent deliveries from space. The chemistry behind it is elegant. When minerals like olivine or pyroxene interact with water, they form hydrated silicates such as serpentine or clay. On small asteroids, this process likely occurred when internal heat briefly melted their icy interiors. The resulting minerals preserved the water within them as the asteroids cooled. Locked inside rock, it could survive eons of exposure to radiation and vacuum, waiting only for impact to release it again. When those impacts struck a planet with gravity strong enough to hold an atmosphere, the water had a place to stay. These stony messengers did more than deliver liquid. They shaped the composition of the oceans themselves. The minerals they carried added dissolved salts and metals, altering the chemistry of Earth's early seas. Over time, those elements would influence everything from the planet's climate to the metabolism of the first living organisms. What began as a geological reaction became a biological inheritance. It is remarkable to think that the oceans covering most of Earth today may owe as much to rock as to ice. We imagine water as something delicate, something that evaporates, freezes, or flows away. Yet here it was, hidden in the hardest materials of all, carried through fire and impact until it could flow freely across a cooling world. In those early days, the difference between sky, land, and ocean was not yet fixed. Volcanic heat boiled away part of what fell, but what remained gathered in basins, dark and restless under a thick, hazy sky. Bit by bit, through the accumulation of rain and the steady gift of impacts, Earth's surface was transformed. Oceans deepened, continents formed their edges, and the planet began to find its rhythm. The water bound in stone had completed its journey. What had once been trapped within minerals now moved freely, filling craters, covering plains, and reflecting the faint sunlight of a young star. In silence, the asteroids had helped finish what the comets had begun, turning a world of fire and dust into one of liquid blue. Even after the bombardment had quieted and the surface had begun to settle, Earth was far from calm. Beneath the crust, heat continued to build. The young planet's interior remained restless, its molten layers shifting and churning like a living thing. Through cracks in the crust, vast plumes of magma rose toward the surface, carrying with them gases that had been trapped deep inside since Earth's formation. When these gases escaped, they thickened the atmosphere further and continued to shape the world above. The dominant gas in those volcanic plumes was water vapor. Alongside it came carbon dioxide, nitrogen, and traces of sulfur compounds. Each eruption sent enormous columns of steam and ash high into the air, darkening the sky for days or even years. Lightning flashed through the clouds of ash. and rain fell back through them in torrents, carving channels into newly solidified rock. The cycle of heat and condensation, of fire and rain, became the pulse of the planet. Over time, volcanic outgassing became one of the most important processes in Earth's transformation. It steadily replenished the atmosphere with moisture and gases that comets and asteroids had already begun to provide. The continuous release of vapor kept the air dense and the surface wet. What had once been a barren world slowly turned into one surrounded by an active, breathing sky. Water was no longer only a visitor from the stars. It was emerging from within the planet itself. Volcanoes covered much of the surface then. They were not isolated peaks, but sprawling fields of fissures that stretched for hundreds of kilometers. Lava flowed across vast plains, cooling in thick layers that built the early crust. Between eruptions, rain fell relentlessly, cooling the rock and feeding the first rivers that ran across the land. Steam rose from every valley, blending with the heavy clouds above. The entire planet seemed to inhale and exhale, water rising as vapor from its fiery breath and returning again as rain. The chemistry of this process was complex but vital. As vapor condensed and fell, it carried dissolved gases that reacted with the cooling crust. Carbon dioxide combined with minerals to form carbonates, locking greenhouse gases into stone and stabilizing the planet's temperature. Water was the medium that made these reactions possible, a solvent that connected the atmosphere and the rocks below. The rain did more than cool. It sculpted the surface, dissolving minerals and carrying them toward the forming seas, enriching the water with salts and elements that would one day become part of living cells. Modern volcanoes offer only faint echoes of that ancient time. In places like Iceland, Hawaii, and Indonesia, steam still rises from vents, reminding us of those early ages when every horizon glowed red with eruption. Even now, volcanic activity plays a quiet role in maintaining the balance of water on Earth. Each eruption releases vapor that joins the atmosphere, continuing the planet's long dialogue between its interior and the sky. It is humbling to realize that much of the water we see today, in oceans, lakes, and clouds, may once have been locked deep within the planet's mantle. Over billions of years, this hidden reservoir has been steadily exhaled through the slow breathing of geology. Earth's water is not merely a gift from space, it is also the voice of the planet itself, a record of its inner heat made visible. If you could stand on the early Earth, you would see that breath everywhere, rising from fissures, drifting in columns of vapor, glowing softly in the dim light of a young sun. The sky would shimmer with moisture, dense with the size of a world releasing its memory of creation. It was through this endless exhalation that balance began to form. The planet had found its rhythm, heat rising, vapor cooling, rain falling. In time, those breaths would shape the face of the earth and feed the seas that would one day cradle life. The steam of volcanoes was not merely the echo of fire, it was the whisper of water returning home. By the time Earth's surface had cooled and water pooled freely across its plains, the foundation of the planet's oceans was complete. But one question remains as old as science itself. Where did all that water truly come from? Was it carried by icy wanderers from beyond the solar system, drawn up from minerals deep within the mantle, or delivered slowly by the endless rain of asteroid dust? The answer, even now, is layered in mystery, a blend of evidence, theory, and wonder that continues to evolve with every new discovery. Scientists have long studied the isotopic fingerprint of water to trace its history. Every source, comet, asteroid, or volcanic vapor carries a unique ratio of hydrogen to its heavier isotope, deuterium. By comparing those ratios to the water in Earth's oceans, researchers can estimate how much each contributor played a part. Some comets show deuterium levels close to our own seas, suggesting that they provided part of our supply. Others differ enough to rule them out. Meteorites, on the other hand, often match Earth's water more precisely, hinting that asteroids may have been the primary couriers. Yet the story is rarely that simple. The rocks that built Earth already contained small amounts of hydrogen and oxygen, locked in minerals that formed before the sun even ignited. As the planet grew, those elements may have combined into water, hidden deep in its mantle. Over time, volcanic activity could have released that water as vapor, feeding the atmosphere until it condensed into oceans. If this is true, then part of Earth's water was born here, not imported from the stars. No single explanation fits all the data. Each new mission, whether it studies comet tails, asteroid samples, or the chemistry of volcanic gases, adds another layer of complexity. It is possible, perhaps even likely, that Earth's oceans are a mosaic of many origins, some drawn from the depths of space, others exhaled from the planet itself. What is clear is that water was present everywhere, in dust, in rock, in ice, long before Earth existed. The universe itself was already wet with possibility. This uncertainty is not a flaw in our understanding, but a reflection of how the universe works. Creation rarely leaves clean lines or single causes. Instead, it weaves multiple processes together until their boundaries blur. Water is the perfect symbol of that blending. It erases edges, softens shapes, and finds balance between forms. Its very nature mirrors the mystery of its beginnings. When scientists look at the Moon, Mars, or the icy moons of Jupiter and Saturn, they find traces of the same molecule that fills our oceans. Some of it frozen, some buried in minerals, some drifting in vapor form above the surface. The same cosmic chemistry that gave Earth its water has touched countless worlds. Ours is simply the one where conditions allowed that water to remain liquid long enough to nurture life. The story of water's origin, then, may never have a final chapter. Each explanation adds depth, but not closure. We can trace its journey from stars to clouds to comets, from molten rock to rain, but the exact path remains blurred by time. Perhaps that is fitting. Water itself is never still for long. It moves, transforms, and connects everything it touches. Its mystery is not meant to be solved completely, only understood as part of the universe's endless cycle of creation. What we do know is that without this blend of sources, this merging of gifts from sky and stone, Earth would be dry and silent. Instead, it glistens. The clouds that drift above, the rivers that wind through valleys, and the oceans that shape our horizon are all products of a process so intricate and ancient that it defies simplicity. The unanswered question of water's origin is a reminder that even the most familiar things can hold the deepest secrets, and that sometimes mystery itself is what keeps the story alive. There came a moment in Earth's long history when the balance tipped. The air, once choked with vapor and dust, began to clear. The surface cooled enough for water to remain liquid, not for moments, but for ages. Rain no longer vanished into steam. It gathered, flowed, and settled into the planet's first basins. The clouds that had hidden the sun for millennia began to thin, revealing light that danced across new oceans. For the first time, Earth reflected blue, a color born of liquid water and sunlight, a quiet announcement that the world had changed. What began as scattered pools joined into vast networks. Rivers carved through the crust, joining basins that deepened with each passing century. Steam rose from volcanic fields and fell again as rain, feeding the cycle that had finally found stability. The planet, once ruled by fire, now moved to a slower rhythm: evaporation and condensation, clouds and storms, waves and tides. In that rhythm lay the first hint of permanence. Water was no longer only visitor or vapor, it was home. The forming oceans covered the surface in sheets that reflected the young sun's light, cooling the planet even further. The thick atmosphere, still heavy with carbon dioxide, began to transform. Water absorbed some of that gas, reacting with minerals to lock carbon into stone. As the skies cleared, light scattered through air and ocean alike, painting the world in the pale blue that would define it forever. Earth had become a mirror, reflecting both sky and sea, the only planet in its neighborhood to glow with such color. This transformation did more than change how the planet looked. It changed how it lived. The oceans began to regulate temperature, absorbing heat during the day and releasing it at night. They carried energy across latitudes, smoothing extremes that would otherwise have made the surface uninhabitable. Wind and current began their endless conversation, redistributing warmth, shaping weather, and carving coasts. The water's movements softened the planet's violence, turning chaos into circulation, fire into flow. From space, the difference would have been astonishing. What had once been a sphere of red and grey became a blue marble swirled with white. Clouds gathered above oceans that stretched unbroken for thousands of kilometers. Lightning still flashed across storms, but now it illuminated a calmer world, one that could sustain oceans instead of consuming them. The color blue became the signature of stability, the mark of a planet that had found equilibrium between sky, land, and sea. In these new waters, the chemistry of the Earth deepened. Rain carried minerals from volcanic rock, dissolving them into the seas and turning them faintly salty. Gases from the air bubbled through waves, exchanging molecules that would one day feed life. The first sediments began to settle on the ocean floor, recording the story of every change, a geological memory that would endure for billions of years. The surface may have looked empty, but the stage was set. The oceans had gathered enough mass to influence everything above them, the thickness of clouds, the balance of carbon in the air, even the length of days through their tug on tides. Water had become the great stabilizer, the silent engineer of habitability. Every storm, every wave, every drop was now part of a planetary system that maintained itself through motion. It is easy to forget that this transformation, from fire to blue, happened without design. It was the result of temperature, chemistry, and time, of hydrogen and oxygen finding their balance under the pull of gravity and light. Yet the outcome was extraordinary. A planet that once glowed like a furnace had become a world of reflection, a world that could cradle the conditions for life. The blue transformation marked not just a change in color but in character. Earth had learned to endure. The oceans, born from dust and fire, had found their place and would remain, cycling endlessly through vapor and rain, shaping continents and skies for the rest of time. Beneath the heavy clouds of the young blue earth, the oceans rolled and steamed, restless under the glow of a faint sun. The water was not yet calm or clear. It was dense with minerals leached from volcanic rock, a mixture of salts, metals, and gases. The surface boiled near volcanic vents, cooled in shadows, and churned endlessly. But within this turbulence, something remarkable was taking shape. The oceans were becoming not only a mirror of the sky, but a cradle, a vast chemical laboratory where the foundations of life were beginning to assemble. At first, there was only chemistry. Simple molecules collided, broke apart, and joined again in countless combinations. Lightning forked across the atmosphere, energizing reactions. Ultraviolet light filtered through a thinner sky, splitting and reshaping bonds. Deep on the ocean floor, hydrothermal vents spewed hot, mineral-rich water into the cold surrounding sea. These vents created pockets of contrast, regions where heat and chemistry interacted in perfect balance, allowing complexity to grow. Within these conditions, carbon-based compounds began to form, linking into chains that could store and exchange energy. No single event marked the beginning. Life did not appear in a spark, but in a slow accumulation of structure and persistence. Molecules that could replicate imperfectly at first began to outlast others. Those that survived copied themselves, making new versions that sometimes changed in small ways. This gradual repetition, shaped by chance and chemistry, laid the groundwork for evolution long before biology existed as we know it. The ocean's role in this transformation was essential. Water was the medium that allowed these delicate molecules to move, collide, and reorganize. It cushioned them from destruction, stabilized their fragile bonds, and provided a space where complexity could increase without burning or breaking apart. Its ability to dissolve and distribute made it the first messenger of connection. In that liquidity, the universe's first living systems found a home. Over time, membranes formed, thin films that enclosed reactions and separated inside from outside. These microscopic boundaries marked a turning point. Within them, chemistry became self-contained, able to sustain itself and grow. Energy from sunlight, or from heat deep below, fueled these early systems. They were small beyond imagining, invisible even to a modern microscope, yet they carried the spark of persistence that would one day evolve into all life. Each tiny drop of water may have held thousands of these proto-living structures, suspended like seeds. Some perished, others endured, and the ones that lasted passed along their patterns in endless variation. The ocean had become a womb of experimentation, patient and vast. Every wave and current mixed its contents, ensuring that new combinations were always possible. Out of that motion came adaptation, the first hint that matter could learn to persist by changing. To stand beside that ocean, if such a thing were possible, would be to witness a planet breathing in a new way. The air would have smelled of sulfur and iron, the water would have steamed with heat. No sound of life would have filled the air, yet beneath the surface, creation was quietly unfolding. The same molecules that had drifted through space for billions of years were now part of a process that would give rise to cells, to organisms, to thought. In this way, the ancient traveler, water, became more than an element. It became the stage and the instrument through which the universe learned to live. Every cell that exists today, from the smallest microbe to the beating heart of a human being, still carries that legacy. Within each of us, the chemistry of those early seas continues, unchanged in principle, still reliant on water to sustain the delicate balance between energy and order. Life began not in fire or in light, but in motion, in the swirling, mineral-rich water of a restless ocean. The same flow that shaped continents and carved the land also shaped the boundaries of living things. The first cradle of life was not a garden or a field, but an ocean, and its lullaby was the sound of waves against a volcanic shore, the voice of the planet beginning to breathe. Once life had found its footing in the seas, the planet itself began to move in harmony with its oldest element. Water became the silent engine of transformation, flowing, rising, and returning in a rhythm that has never stopped. It evaporated from warm surfaces, lifted invisibly into the air, condensed into clouds, and fell again as rain. It froze, melted, seeped, and surged. Every drop that left the ocean's surface eventually returned, completing the first true cycle, the hydrologic loop that would shape the destiny of the Earth. In those early ages, the continents were still forming, and the face of the planet was far from settled. Volcanoes exhaled steam into the sky, while earthquakes lifted mountain ridges from the ocean floor. Through all this turbulence, water worked patiently, carving, cooling, dissolving. Rivers formed wherever the land tilted, tracing new paths toward the sea. The rain that fell on volcanic rock carried with it small traces of minerals, sodium, calcium, magnesium, the same elements that still make seawater salty today. In a sense, the oceans were not just filled by water, they were fed by stone. This constant movement gave the planet its living texture. Even when life itself was simple and microscopic, the Earth's surface was alive with circulation. Water linked the atmosphere and the crust, the depths and the heights. Heat from the sun drove evaporation, the pull of gravity returned it as rain. The same molecules that formed in ancient clouds of interstellar dust now danced in an endless exchange between sea and sky. Nothing stayed still, nothing was ever lost. In the rhythm of evaporation and rain, the planet found balance. When the days grew hotter, Clouds gathered to soften the heat. When the air cooled, the rains eased, giving the ground time to rest. This self-regulating system, born of simple physics, became the planet's heartbeat. It was an unbroken flow that carried energy and matter around the globe, eroding mountains, building deltas, and shaping coastlines. Even now, that same rhythm continues, indifferent to time, endlessly renewing the surface beneath our feet. The movement of water also carried life outward. Tiny organisms drifted with the currents, spreading from the deep ocean vents into sunlit shallows. In rivers and lagoons, new forms began to adapt, learning to live where tides met land. Every migration, every adaptation depended on water's ability to move, to connect one place to another, to erase isolation. In this way, water became the planet's first traveler not only across space, but across biology. It carried life wherever it went, dissolving boundaries, linking every environment into one vast, breathing system. The cycle's elegance lies in its permanence. The same water that filled ancient seas still circulates through clouds above you now. It has changed shape countless times, frozen as ice in glaciers, drifted as vapor in the air, pressed through rock as groundwater, and flowed again as rivers to the sea. The molecules themselves are ancient, but their movement is ceaseless, turning every drop into part of a story without beginning or end. If you could follow a single molecule of water through its journey, you might find it in a wave today and in a snowflake a year from now, in a river the next, in a cell of living tissue centuries later. It might return to the clouds, fall again, and enter the ocean once more. Over millions of years, it would travel from pole to equator, from mountain peak to deep trench, never lost, only changed. This endless motion defines Earth as a living world. The rocks hold memory, the air carries breath, but water brings continuity. It makes every transformation reversible, every ending a new beginning. The streams that cross the land and the tides that rise and fall are not random events. They are echoes of the same process that began in the first mists of the universe. Water, the first traveler, never stopped moving. It flows through time as surely as it flows through valleys and clouds, binding together the history of the planet. The rain that falls, the mist that drifts, the river that runs to the sea, all are part of one great motion, repeating endlessly, reshaping the world while remaining, in essence, the same. As the eons unfolded, the water that had cradled the first living forms continued to circulate through every corner of the planet. The oceans, already billions of years old, became archives of memory, silent witnesses to the rise and fall of species, to the slow drift of continents, and to the ceaseless transformation of life itself. Every organism that lived and died returned some part of itself to the water. It absorbed and released, preserved and renewed, never letting go of its role as the planet's unbroken thread. The connection between past and present runs deeper than it seems. The same molecules that once surrounded the first living cells still move through our world today. They have passed through the gills of ancient fish, the roots of prehistoric forests, and the lungs of animals that walked long before humanity. When you drink from a stream or watch rain fall across the sea, you are touching the same element that sustained creatures lost to time, a liquid archive carrying the breath of eras. Through this endless recycling, water became the great storyteller of the earth. The atoms within it, hydrogen from the dawn of the universe, oxygen forged in ancient stars, have been part of every generation of life. A single molecule may have drifted in a shallow sea where trilobites once crawled, evaporated into clouds above a primeval forest, fallen as snow onto a glacier that later melted into the ocean, and now exists in a river that flows past our feet. Each transition leaves its faint imprint, a whisper of continuity that binds all living things together. When dinosaurs roamed beneath tropical skies, their bodies were full of water, no different from ours. The rain that cooled their skin, the rivers they crossed, the lakes they drank from, all part of the same cycle that still feeds every plant and creature today. After their extinction, that same water remained, carrying traces of their existence as it continued its ceaseless journey through atmosphere and soil. In this way, nothing in nature truly vanishes. It merely changes form, moving from one life to another through the patient medium of water. The oceans hold the clearest proof of this continuity. In their depths, life evolved into countless forms: coral reefs, whales, plankton, and the drifting larvae of new species. Each depended on the same basic chemistry: water as solvent, as transport, as the framework for energy and metabolism. Even now, the ratio of salts in our blood reflects the chemistry of those ancient seas. It is as though we never truly left the ocean. We carry a small version of it within us, flowing through our veins. On geological timescales, water records its stories not in words, but in layers: ice cores, sediment, fossils, and isotopes. Within these, scientists can trace the changes in temperature, atmosphere, and life across billions of years. Every droplet that freezes into ice or settles as silt preserves a moment of history. When it melts or dissolves again, it releases that memory back into circulation. The planet's memory is not written in stone alone. It is written in the movement of water, continuous and eternal. It is humbling to realize that the water you hold in a glass today could once have fallen as rain on the first forests, or cycled through the body of a mammoth crossing a frozen plain. It may have risen as vapor from the sea that surrounded the first continents, or frozen into ice at the edge of a vanished glacier. The atoms are the same: ancient, patient, unchanged. Only their arrangements vary, their journey never-ending. Each breath of mist, each ripple on a lake, each snowflake that melts into the soil carries echoes of the deep past. Water remembers without consciousness, storing the chemical trace of every living thing it has ever touched. It connects us not just to one another, but to all who came before: the forgotten, the extinct, the unseen. In its endless flow, water holds the Earth's entire biography. And in that continuity lies a quiet truth: life and water are inseparable, not only in origin but in destiny. As long as water moves, the memory of life endures, carried forward, reflected, and renewed in every wave, every raindrop, every living cell that still listens to its ancient rhythm. Above the oceans, where the sunlight warms the surface, water begins to rise again. Invisible at first, it turns to vapor and drifts upward, carried by air currents that circle the planet. There, in the cool layers of the atmosphere, it gathers into clouds, floating reservoirs of Earth's memory. Each cloud is a temporary collection of the same ancient molecules that once lay in deep seas or flowed through rivers. They travel together for days or weeks, crossing continents, carried by winds that have blown since the dawn of time. Inside these clouds, condensation forms tiny droplets around dust or salt particles. Millions of them cluster together, refracting light and giving the sky its shifting tones of grey and white. The beauty of clouds lies in their impermanence. They are in constant motion, building and dissolving, never quite the same from one moment to the next. Yet every drop they carry is old, a traveler that has cycled through oceans, glaciers, and living bodies countless times before. The sky holds all that history, suspended above us like a living archive. When sunlight filters through their edges, clouds tell the story of balance, energy rising, cooling, and returning as rain. They are not merely decoration in the sky, but a vital part of the planet's circulation. Without them, there would be no climate, no rivers, no renewal. They reflect sunlight, cooling the Earth during the day, and trap warmth at night, keeping temperatures stable. Every wisp of vapor participates in this delicate equilibrium, adjusting the planet's breathing with silent precision. The movement of clouds across the globe connects every region to every other. Water that evaporates from a tropical sea may fall weeks later, as snow in a distant mountain range. A drop that leaves the Pacific might end its journey in an Arctic glacier. In this way, the atmosphere erases borders, carrying water, and with it, memory, freely across the world. Every cloud that passes overhead is built from vapor that has traveled through many lifetimes of the planet. For ancient cultures, the sky's changing forms were messages from beyond. The drifting of clouds foretold rain, harvest, or storm. They were read like letters written in motion, messages from gods or spirits. Science now tells a different story, yet the sense of wonder remains. Clouds still connect heaven and earth, holding the past in suspension until gravity calls it back down. They are the voice of water between its resting places, a reminder that what falls today once rose from somewhere else long ago. Even their shapes carry meaning. Cumulus clouds tower like mountains of vapor, echoing the land below. Thin cirrus streaks trace the direction of winds that circle the entire planet. Every pattern reveals the physics of moisture and air, yet together they form an ever-changing artwork, a fluid record of the planet's moods. And when the rain begins, the memory is released. Droplets gather weight, fall through layers of air, and finally return to the surface. Some land on ocean waves, completing their journey in moments. Others strike soil, sink into the ground, and begin new travels through rock and root. Rain connects sky and earth as pulse connects heart and body. It is the physical manifestation of the planet's memory returning to where it began. When you watch clouds move or feel rain on your skin, you are part of that ancient circuit. The same molecules that once rose from the oceans of a newborn world now touch your hands. The water that evaporates into the sky will someday fall again, perhaps far away, on another ocean, another forest, another person. The atmosphere carries not only vapor but continuity, a memory written in motion. Every cloud that drifts above is the sky remembering what it once held. It is the earth's breath made visible, the trace of oceans lifted toward the stars. And when it rains, that breath returns home, whispering again the story of connection that has never stopped. The sky remembering, the earth receiving, and water, the eternal traveler, flowing quietly between them both. In the farthest reaches of the planet's poles, where the air itself seems to sleep, water preserves its memory in a different form. It lies locked in ice, silent, layered, and luminous beneath the pale light of the sun. Each winter buries a thin sheet of snow upon the last. Each summer presses that snow into denser crystals. Over time, these layers become a solid record, a frozen diary of the Earth's breath. What appears to be simple whiteness is, in truth, a library of time. Every centimeter of ice holds the story of a year. Within it are tiny bubbles of ancient air, grains of dust carried by long-vanished winds, and faint traces of chemical change that mark distant volcanic eruptions or shifts in temperature. When scientists drill deep into glaciers and polar caps, they draw up cores that can reach back hundreds of thousands of years. By studying the gases trapped inside, they can read how the planet's atmosphere has changed, the rise and fall of carbon dioxide, the rhythm of ice ages, the warming and cooling that shaped the path of life. These frozen records remind us that water is not only movement but memory made solid. In its stillness, ice protects the evidence of what once was. Each layer, though silent, speaks of storms long ended, of seas that rose and withdrew, of forests that spread and vanished. It is the patient handwriting of time, etched not in ink but in crystal. The physics of it is simple, yet profound. As snow compresses, air is sealed into pockets that no longer exchange gases with the atmosphere. Those bubbles preserve the composition of the air exactly as it was when the snow first fell. The deeper the layer, the older the sample. Some cores from Antarctica reach back nearly 1 million years, showing cycles of climate that move like a slow heartbeat through history. They reveal how even the smallest variations in sunlight or orbital tilt can ripple through the entire planet, altering oceans and air in a delicate dance of cause and effect. Standing on a glacier, the world feels motionless. The surface is smooth, the horizon pale and quiet. But beneath that calm lies constant movement. Ice flows inch by inch toward the sea. It creaks, fractures, melts, and refreezes. Slow, immense motion that reshapes continents. The stillness is an illusion. Even frozen water remembers how to move. In its gradual descent, it carries with it the past, delivering ancient air to the ocean in a final act of release. For all its strength, ice is fragile. A shift in temperature can erase centuries in a single season. When glaciers melt, the pages of that frozen book vanish into the sea, and the record is lost. The planet warms, and the memory thins. Yet some part of it endures, in remaining ice sheets, in deep cores stored in laboratories, and in the collective awareness that these layers once held our history. The frozen archives remind us that water is both historian and participant. It records the planet's transformations even as it drives them. In vapor, in liquid, in solid form, it continues to translate energy into motion and memory into matter. Each flake of snow that falls today may one day join that archive, pressed by weight and time into a new chapter of ice. The stillness of the poles is not emptiness but concentration, a silence so complete that the world's past can rest within it. Beneath that frozen surface, the story of Earth waits patiently, preserved in crystal clarity, until the next thaw begins to turn memory back into motion once more. Every person carries a small echo of the sea inside. Our bodies are made mostly of water, not as a metaphor, but as chemistry. In every cell, in every pulse of blood, the same molecule that shaped the planet flows through us. The saline balance of our blood mirrors that of the ancient oceans where life first appeared. Long after the first organisms left the water, the ocean came with them, sealed inside the soft architecture of flesh. Within each heartbeat, water moves through a vast network, arteries, veins, capillaries, an internal tide that never ceases. It transports nutrients, clears waste, cools and warms. It cushions organs, lubricates movement, and carries electrical signals through dissolved minerals. Sodium, potassium, and calcium drift through the bloodstream like elements of a small, personal sea. Each rhythm of the heart is a wave, each breath a tide. This quiet circulation connects us to the planet's larger systems. The evaporation of a lake, the rain that falls, the sweat on our skin, all part of the same unbroken exchange. The water within us does not belong solely to us. It leaves, returns, and leaves again, continuing a cycle that began long before humans existed. When we exhale, we release vapor into the air. When we drink, we draw back into ourselves the ancient molecules that once drifted among the stars. We are both vessel and participant in the planet's endless circulation. From a biological perspective, this link is fundamental. Water is the solvent of life, the medium in which every reaction inside us takes place. Without it, no cell could function, no signal could pass, no energy could move. Proteins fold correctly because they are surrounded by water. DNA holds its shape because of the bonds water forms along its edges. It is not simply present in the body, it defines the body's architecture. Every thought, movement, and heartbeat depends on its quiet assistance. The ocean within us is older than our species, older than the continents we stand on. It began forming the moment Earth cooled enough for rain to fall. Through evolution, the chemistry of those early seas shaped the chemistry of our blood. Even now, when we taste salt on our lips, we taste the memory of those primordial waters. The connection is so complete that to lose too much water is to lose balance itself. A body without enough of it forgets how to regulate heat, loses the rhythm of circulation, and falters. This internal sea also shapes how we feel and perceive. The flow of water affects temperature, energy, and emotion. The sound of waves, the rhythm of rainfall, the stillness of a lake, all resonate because they mirror what already moves within us. When people find calm near the ocean, it may be recognition rather than mystery, the body hearing its own rhythm reflected back. Across cultures, this connection has been recognized instinctively. Ancient physicians described the body's humors as tides. Spiritual traditions compared breath to waves, seeing life itself as a motion between inhalation and exhalation, presence and release. Even modern science, with its instruments and equations, acknowledges what those early observers intuited, that life and water are inseparable, two expressions of the same continuous flow. To think of ourselves this way changes perspective. We are not separate from the planet's circulation, but a continuation of it. The rain that falls may become part of us. The water we release may drift upward to form clouds again. Every tear, every drop of sweat, every breath of mist joins the same atmosphere that once belonged to ancient oceans. The boundaries between body, air, and sea are fluid, just as they have always been. In that realization lies a quiet kind of belonging. The water within us does not end at our skin. It reaches outward, connecting each of us to the larger body of the earth. To live is to participate in the planet's rhythm, to carry the ocean's pulse in miniature form. We are each a small, moving reflection of that vast, patient sea that gave the world its life and continues to flow through all living things. For a long time, Earth seemed alone in its abundance of water. The other worlds of the solar system appeared dry and silent, their surfaces scarred by time. Yet, as technology sharpened our vision, that perception began to change. The same molecule that fills our oceans and flows through our veins has been found across the cosmos, hidden beneath ice, drifting in vapor, or frozen in the shadows of distant moons. Water, it seems, is not rare. It is one of the universe's most patient and persistent travelers. On Mars, traces of ancient rivers snake across the surface like the ghosts of vanished seas. Satellite images reveal dry deltas and shorelines that once held lakes. Ice still lies beneath the red dust, and at the poles, and sometimes, in the thin air, a faint fog gathers in the morning cold. Long ago, when Mars was warmer and its atmosphere thicker, water may have flowed freely there. Now it waits beneath rock and frost, a frozen memory of a planet that once resembled our own. Farther out, among the moons of Jupiter and Saturn, water hides in places of extraordinary contrast. Europa, smooth and bright, is covered by a crust of ice that conceals an ocean deeper than all Earth's seas combined. Beneath that shell, tidal forces from Jupiter's gravity create heat, keeping the water liquid. Plumes of vapor occasionally erupt through cracks, jetting into space, clear evidence of an ocean world beneath the frozen surface. Nearby, on Saturn's moon Enceladus, similar fountains spray from its southern pole, carrying salt and organic compounds into the void. Each plume is a sign that even in darkness, water persists. These discoveries have transformed our understanding of habitability. Where there is water, there may be the chemistry of life. It provides stability, dissolves nutrients, and protects delicate molecules. NASA's spacecraft, the European Space Agency's probes, and the James Webb Space Telescope all continue to trace water's fingerprints in the atmospheres of exoplanets, in vapor around newborn stars, and even in the disks where new worlds are forming. Everywhere astronomers look, they find evidence of its presence. The realization is profound. The conditions that made Earth blue are not unique. Water exists wherever temperature, pressure, and chemistry align just enough to allow it. It may be locked in rock, flowing beneath ice, or drifting as steam through interstellar clouds. Its abundance means that the potential for life is written across the universe in liquid lines. This knowledge deepens rather than diminishes Earth's meaning. The oceans that surround us are part of a larger story, one that extends far beyond our skies. The same processes that shaped our planet are at work elsewhere, guided by the same laws. When we look outward, we are, in a sense, looking backward, seeing echoes of our own beginnings reflected across the galaxy. The thought that countless worlds may hold their own hidden seas is both humbling and inspiring. It suggests that water is not only the traveler between stars, but also the thread that ties them together. It carries the same ingredients that once sparked life here, moving quietly through time and space, waiting for the right conditions to begin again. If we could listen closely to the universe, we might hear the same rhythm everywhere: the sound of condensation, the silence of ice, the soft pressure of liquid against rock. It is the sound of possibility. The search for water beyond Earth is not just a scientific pursuit. It is a reflection of longing, a reminder that the essence of what made us may exist elsewhere, still waiting to awaken under another sun. In this way, the discovery of water across the cosmos does not make our oceans smaller, it makes them infinite. Each drop on Earth becomes a part of something greater, a universal element shared among stars, planets, and time itself. Amid the immensity of the cosmos, Earth occupies a fragile position, a narrow band of distance from the sun where water can exist in all its forms. Too close, and the heat would strip it away. Too far, and it would freeze forever. This narrow zone, known to astronomers as the habitable zone, is a corridor of delicate equilibrium. Within it, temperature, atmosphere, and gravity conspire to create the rarest of circumstances, a planet that can remain blue. The conditions that sustain this balance are both simple and astonishingly precise. The sun provides warmth, but not too much. The Earth's orbit is nearly circular, keeping that warmth steady through the year. The planet's size allows it to hold an atmosphere thick enough to trap heat, but light enough to avoid crushing pressure. A magnetic field, born from the molten core, deflects solar radiation that would otherwise strip the air away. The tilt of the Earth's axis spreads sunlight unevenly, creating seasons and circulation. Each of these factors works together like the components of a vast, invisible machine. If any part shifted too far, the system would falter. Venus offers a glimpse of what could have been. Though similar in size and composition to Earth, it lies just a little closer to the sun. That small difference led to catastrophe. Early water vapor in its atmosphere trapped more heat, which caused further evaporation, a runaway greenhouse effect that boiled its oceans away. Now, Venus is a furnace wrapped in clouds of acid, its surface hot enough to melt metal. Mars, by contrast, lies just beyond the habitable range. Too small to retain a thick atmosphere, it lost its warmth and water to space. What remains are the dry echoes of rivers that once flowed. Between these two extremes, Earth maintains its narrow line of balance. The atmosphere filters sunlight, letting through enough energy to sustain life while blocking the most harmful radiation. Greenhouse gases, often spoken of as threats, are, in the right amounts, part of this harmony. They trap just enough heat to prevent the planet from freezing. The oceans themselves act as stabilizers, absorbing excess warmth and releasing it slowly. Ice caps reflect sunlight, regulating global temperature. Even the distribution of land and sea helps to spread heat evenly around the globe. It is a design not of intention but of coincidence, a natural symmetry that sustains water in its liquid state. This equilibrium is dynamic, always shifting, never static. Over geological time, the planet has tilted, cooled, and warmed. Yet the system has always found its way back to conditions where water can flow. It is as though the Earth remembers its own balance and strives to keep it. Within that balance, life emerged, adapted, and flourished, building ecosystems that in turn help to stabilize the climate further. Forests, coral reefs, and plankton all became parts of the same feedback loop that began with water's simple ability to absorb and release heat. To study this balance is to see how rare our situation truly is. Across the billions of stars in our galaxy, planets are common. Yet, the right combination of atmosphere, magnetism, temperature, and water remains elusive. The more we learn, the clearer it becomes that Earth's steadiness is an exception rather than the rule. And yet, despite its rarity, this balance is not unchangeable. The same forces that created it can be disrupted by volcanic eruptions, asteroid impacts, or human influence. The climate's stability depends on a relationship so intricate that even small changes can ripple across centuries. Still, the system endures, adjusting and recovering as it has for billions of years. When viewed from space, the Earth's blue glow appears effortless, but it is the result of constant motion and fragile equilibrium. Every cloud, every current, every molecule of vapor participates in maintaining that line between freezing and boiling, between silence and life. To exist here, surrounded by water that neither vanishes into steam nor locks away as ice, is to inhabit a narrow miracle, a balance so rare that it defines our place in the universe. Long before the language of science, people looked upon rivers, rain, and oceans with reverence. They sensed instinctively what we now confirm through chemistry and physics, that water is the foundation of life, the silent current linking all beings and places. Across cultures and centuries, it has been worshipped, feared, and celebrated, not because of mystery alone, but because of recognition. To live near water was to live, and to lose it was to vanish. Ancient civilizations built their homes beside rivers that nourish both land and spirit. The Nile, the Indus, the Yangtze, and the Tigris carried not only silt and sustenance, but stories and meaning. These waters flooded, withdrew, and returned with the seasons, teaching early societies that time itself moves in cycles. Each flood was destruction and renewal in one act, a rhythm humanity learned to measure its own existence by. In that rhythm, people heard divinity. In Egypt, the Nile was seen as the bloodstream of the god Osiris, its annual flooding a resurrection that made the desert bloom. Along the Ganges, water became a living goddess, capable of washing away impurity and granting passage to spiritual liberation. In Japan, the Shinto tradition honors waterfalls and springs as dwellings of kami, the sacred spirits of nature. The Greeks imagined Oceanus, a river encircling the world. The Hebrews described the breath of creation moving over the waters before light was born. These stories, distant yet similar, reveal something universal in human perception. Wherever people encountered water, they found reflection of life, of time, of themselves. The same fluid that shaped mountains and nourished crops also stirred emotion and thought. It mirrored the sky, responded to touch, and refused to be grasped. It could cleanse and destroy with equal ease. To early minds, it was not merely a substance. It was a living principle that moved between worlds, joining matter and spirit in one continuous flow. Modern science gives new language to that reverence without replacing it. We understand now that water carries not just spiritual but physical renewal. It cycles through every organism, washing cells, dissolving waste, sustaining growth. In deserts, it marks the difference between barren silence and the sudden burst of green. In the human body, it flows through the same patterns, circulating, purifying, balancing. The logic that early myth expressed through divinity, we now describe through biology and physics. Yet the ore remains the same. There is a reason rituals of cleansing appear in nearly every culture. To bathe in a river, to step into the sea, or to feel rain on the face is to reenact the planet's oldest story, transformation through water. In washing, people symbolically return to the beginning, to the time when all life was immersed, when every cell was surrounded by the same salt water that still fills our veins. Even today, we instinctively seek the comfort of water when we need renewal. We travel to the shore, sit beside fountains, or listen to the steady rhythm of rain. Water's sacredness lies not in superstition but in continuity. It has witnessed every stage of Earth's history and every chapter of human culture. The same rivers that carved ancient valleys still flow through modern cities. The molecules that once turned desert sand to fertile soil now pass through pipes, clouds, and bodies, unchanged in essence. To revere water is to acknowledge our dependence on what predates and outlasts us. When we look at a river, we see movement, reflection, and light, but we are also looking into the memory of our own origins. That recognition unites science and faith in a single understanding that water connects all things. It bridges time, matter, and meaning. Whether as flood, rain, or ritual, it continues to remind us of a truth older than words, that renewal, like water, must always return. If you look closely at a single drop of water, it appears simple, clear, weightless, without color or shape of its own. Yet inside that drop lies a structure so precise and elegant that it governs the behavior of oceans, clouds, and every living cell. Water's power comes not from complexity, but from the perfect geometry of its smallest form, two atoms of hydrogen bound to one of oxygen, arranged in a shape that tilts just enough to make one side slightly positive and the other slightly negative. That subtle asymmetry is what allows the universe's most common liquid to perform its quiet miracles. Because of this polarity, water can link with itself. Each molecule forms temporary bonds with its neighbors, joining and breaking billions of times per second. These hydrogen bonds give water its unique character, its surface tension, its ability to dissolve so many substances, its expansion when freezing, and its capacity to absorb and release heat without extreme change. Without this molecular behavior, there would be no stable climate, no protective oceans, and no living membranes to contain life. The structure of water is an architecture of balance. It bridges opposites, solidity and fluidity, heat and cold, stillness and motion. When it freezes, its molecules form open patterns that occupy more space, allowing ice to float. This one detail ensures that lakes and seas do not freeze solid from the bottom up, preserving life beneath the surface. In liquid form, those same molecules move close enough to flow while still maintaining connection. It is as if water remembers structure even in movement, carrying order through change. Within a single droplet, countless interactions happen at once, molecules vibrating, bonding, breaking apart, reforming. Each vibration echoes the motions of planets and stars, a rhythm governed by the same physical laws. At this tiny scale, time behaves differently. Reactions occur in fractions of a second, yet they mirror the processes that shape worlds. In every droplet, energy is exchanged and stored as light warms its surface and gravity pulls it downward. It is the smallest theater of the cosmos, performing its pattern endlessly. When light passes through that drop, it slows slightly, bending to reveal the colors of the spectrum. Rainbows are not just beauty but physics, light refracted through countless identical shapes. Each color we see in the sky is born from this interaction, a dialogue between water's geometry and sunlight's energy. In that sense, even the arc of a rainbow is a reminder of how deeply the laws of nature depend on the quiet order of water. Scientists have studied water's behavior for centuries, yet it continues to surprise. Its properties defy easy explanation. It should boil at a much lower temperature, freeze at a much higher one, and weigh less than it does. It does none of these things. It exists in ways that calculations once predicted impossible, as though the universe adjusted its parameters just enough to allow water to be what it is, the gentle medium in which complexity can exist. To hold a drop in your hand is to hold time itself. The hydrogen within it was born in the first seconds after the Big Bang. The oxygen was forged in ancient stars. Their bond began billions of years ago, and in all that time they have never ceased moving. That drop may have once floated in a cloud above a prehistoric forest, or frozen inside a glacier, or flowed in the bloodstream of a creature now long gone. Each molecule has participated in every form of the planet's history. A drop of water is small enough to disappear on a fingertip, yet vast enough to contain the story of the universe. It is proof that simplicity and mystery can exist together, that the most common things are often the most profound. To see a droplet fall is to glimpse eternity in motion, a brief reflection of everything that has ever been, carried quietly within a single, transparent form. All water that has ever existed is still here. It may change form, wander from one state to another, but it does not vanish. Every drop that fell in the first rains still moves through the planet's endless circuit, rising, falling, freezing, melting, flowing. This continuity makes water not just a substance, but a living sequence, a river of ages that connects the newborn Earth to the present moment. From the slow drip of mountain springs to the vast migrations of ocean currents, water travels in patterns both visible and hidden. It moves through the atmosphere in invisible streams, circles the poles as frozen caps, and courses through the ground as veins of groundwater older than any civilization. What begins as a raindrop in one place might, centuries later, emerge from a different shore, reborn as mist or tide. Time does not stop it, it only changes its path. The hydrologic cycle is the engine of this continuity. Driven by sunlight and gravity, it moves water between sea, sky, and land, redistributing heat and matter across the entire planet. Evaporation cools the surface. Condensation releases warmth into the atmosphere. Rain nourishes the soil. Rivers carve valleys, and runoff returns to the sea. Every step sustains another, a balance so complete that the whole Earth breathes in rhythm with it. To trace this movement is to witness the planet's pulse. Even underground, water never rests. It seeps through pores and fissures, dissolving minerals as it goes, carrying traces of rock and metal that will later feed plants and creatures. In deep aquifers, it sleeps for thousands of years, untouched until it emerges again through springs. These hidden flows remind us that movement need not be visible to be real. Beneath our feet, slow rivers glide through stone, linking mountains and valleys in silence. Across the oceans, the great currents perform the same work on a planetary scale. Warm water drifts from the equator toward the poles. Cool water returns along the depths, circulating energy that stabilizes climate. These global rivers are vast but obedient to the same laws that guide a single drop. They connect all seas into one, ensuring that the world's waters are not separate bodies but limbs of a single organism. The River of Ages also carries memory. Sediment suspended in a stream holds fragments of mountains long eroded. Icebergs carry dust trapped from distant deserts. Even clouds contain salt from evaporated seas. Water gathers the traces of everything it touches and carries them onward, blending past and present until they are indistinguishable. Each wave that reaches the shore contains a fraction of everything the world has been. Through this circulation, water writes the planet's biography not in a line but in a loop. There is no first or last chapter, only perpetual return. What falls as rain today may rise as vapor tomorrow, to fall again on another continent centuries later. It is the same for life. The water that nourishes a seed may one day flow in a river or become part of a human heartbeat, and then return once more to the sea. All things that live borrow from this continuity for a moment and then give it back. It is difficult to find permanence in a world defined by change, but water offers a form of endurance that is not stillness but persistence. Its motion never stops, yet its total remains the same. A balance achieved not through rest, but through ceaseless exchange. That is the quiet law of the River of Ages. Nothing truly leaves, everything returns. To stand beside a river and watch it move is to witness time in physical form. What you see has flowed from rain that fell before your birth and will continue long after you are gone. In that motion lies the reassurance that life, too, is part of an unbroken circulation, not fleeting, but continuous, always passing forward, always finding its way back. If the story of water teaches anything, it is that endurance need not be rigid and that strength can live in motion. Across billions of years, water has been reshaped endlessly, vapor to ice, droplet to wave, river to sea, yet never destroyed. It adapts without resistance, changes without fear, and returns without loss. In its patience, it carries the quiet wisdom of the universe itself. The first traveler has never stopped moving, and through that movement it has bound all things together, from the explosions of stars to the cooling of planets, from molten crust to breathing forests. Water has been present at every threshold. It asks for no permanence and claims no territory. It occupies every form offered to it, then moves on. The seas that cradle continents will one day evaporate into sky. The clouds that drift above will fall again as rain. In every transformation, nothing essential is lost. The molecule endures, as it has since before Earth was born. In this constancy through change lies a reflection of balance, the same principle that governs stars, atoms, and life itself. The hydrogen that forms water's core was created in the first seconds after time began. The oxygen joined it billions of years later, inside dying stars. That union, born of both fire and stillness, became the foundation of everything alive. To follow water's path is to see how chaos shapes order and how destruction gives way to creation. The traveler's lesson is subtle but unmistakable. It shows that connection is not a choice but a law. Every breath exhaled, every river flowing to the sea, every cloud crossing the horizon is part of the same sequence. Separation is an illusion of scale. The molecule that drifts through you today may one day rise from the ocean and fall as rain on another shore. We are not apart from this movement. We are made of it. Through water, the universe demonstrates how diversity can coexist with unity. Each droplet behaves individually, yet moves with all others toward the same equilibrium. This quiet cooperation is written into its chemistry, hydrogen bonding to oxygen, forming networks that hold together while constantly breaking apart and reforming. In that rhythm lies the secret to survival. Flexibility joined with cohesion, persistence without rigidity. Perhaps that is why water has always inspired both science and reverence. It obeys the strictest laws of physics, yet evokes the deepest sense of mystery. It can carve stone, carry continents, and cradle life, yet it yields to every obstacle without aggression. It embodies harmony through adaptability, strength through gentleness. In its presence, the universe reveals one of its simplest truths, that continuity is not maintained by power, but by flow. When we look across a river, we see our own reflection, not only in the surface but in essence. The same atoms that shaped galaxies now move quietly within us, repeating the same motions they have performed since the beginning of time. To understand water is to understand our place in that continuity, not as masters of nature, but as participants in its ongoing current. The traveler's journey reminds us that permanence exists only through transformation. The drop that falls today may rise tomorrow. The ocean that glimmers now will one day turn to vapor and return again. What begins in one form always finds its way to another. Water does not resist change, it becomes it. And so, the lesson of the first traveler is one of acceptance and unity. The molecule that crossed galaxies to reach this world flows still through our veins. Its story is our story, the story of movement, resilience, and renewal written in the simplest of bonds. To listen to that story is to hear the universe speaking softly through every stream and wave. Nothing is separate, nothing is lost. Everything flows, forever returning to itself. As this story draws to a close, the traveler rests once more. Water has journeyed from the birth of stars to the blue calm of oceans, from clouds to cells, from the silence of ice to the pulse of blood. It has carried light, sound, and memory through every transformation, binding the universe together through motion and return. To follow its path is to see the unity of creation, a single molecule weaving through fire and frost, through life and time, never ceasing, never ending. Tonight, as you breathe, the same element moves quietly within and around you. The vapor in your lungs, the moisture in your skin, the dew gathering outside your window, all are part of the same unbroken current that began before the earth existed. The first traveler is still here, circulating through oceans, clouds, and people alike, flowing through everything that lives and everything that has ever been. The physics of its motion is simple, yet its meaning feels endless. Hydrogen from the dawn of the universe meets oxygen from ancient stars, joining again and again in the chemistry of existence. Every bond they form, every droplet they create, keeps the world alive. From cosmic dust to river mist, from glacier to rainfall, water connects all scales of being, the infinite and the intimate, the vast and the near. Look at the sky, and you may sense that movement continuing far beyond sight, vapor drifting upward, condensing and falling again in a cycle that never tires. It is the same breath the planet has taken for billions of years, the same rhythm that calms seas and guides the quiet rotation of clouds. In that repetition, there is peace. It reminds us that nothing truly stands apart. Everything that changes returns. Everything that falls rises again. You may find comfort in knowing that as you rest, the world continues its quiet work. Rivers flow unseen in the dark. Clouds gather softly across the horizon. Tiny droplets form in the cool air, waiting for dawn. Water continues its journey without haste, fulfilling its ancient promise to connect every corner of the earth. The same molecule that once drifted between stars now rests near you, carrying the memory of everything it has touched. If sleep comes easily, let it. If it lingers, that is completely fine. You can still rest in the rhythm of this continuity, the calm assurance that even while you sleep, the same cycle that formed the world carries on. Simply breathe and know that your breath is part of the planet's exchange with the sky. The first traveler's journey never truly ends. It continues in every droplet and tide, in every heartbeat and cloud, reminding us that motion itself is life. Tonight, that motion slows around you, settling into stillness. The story remains, flowing softly through the world, patient as the water that shaped it. We thank you for listening, for sharing this quiet time between thought and rest, a moment suspended within the same continuity that holds stars, oceans, and dreams. We from Sleepy Stories wish you a good night.